Welcome to another triangle similarity problem. Let's find out if this triangle are similar. If it is so, we're going to write a triangle similarity statement. Okay, the first one gives us a triangle JHJ and triangle FHK. Let's take 2 letters at a time. So the first corresponding side is JH to FH. And the next one, we're going to take HJ to HK. And next one, we're going to go this direction. Of course, you can go to JJ or FK. And we're going to write J and KF. Then we're going to look at the given values, see if they have the same ratio. If they have the same ratio, that means yes. By side similarity rules, it is these 2 triangles are similar triangle. It is true. Okay, let's look at a J. We don't know yet. I just put down here said A. So we're going to calculate really quickly. JH is 15. FH is 15 plus 5. And then we have HJ is 16.5, and plus JK, that is gives us HK. So, and then JJ is 18 and 224. Go ahead and simplify, and you should be able to find that it is 4 to 3. So yes, they carry 4 to 3. 4 to 3, same ratio. So they have this proportional relationship. Therefore, we say yes, these 2 triangles are similar. By what kind of rule? By side similarity theorem. Okay, that is our question 1. I'm going to erase here and make more space for the next question. Next question gives us a triangle ABC and a triangle DEC. Therefore, we can take 2 letters at a time. We take AB and DE. We write down AB to DE. The next 2, BC to EC, BC to EC. And next 2, you can do AC and DC. And then we're going to calculate, okay? AB to DE, we don't have it, but that's okay. Leave it blank because something else is going to happen, okay? BC to DC. BC is 21 and EC, BC to EC. And simplify. Okay, so we have 3 to 2. That's a ratio. Let's look at AC to DC. AC is 27. DC is 18. It's also 3 to 2, which means we have 2 pairs of corresponding sides. They have the same ratio. So we have a side. Now let's look at here. Isn't it true? These 2 angles, I'm going to call it angle 1 and angle 2. They have the same angle measure. They're congruent. Why? Because vertical angle is congruent, which means we can use our new rule. We have this angle here. Our new rule is called side angle side similarity theorem. We have a side, we have an angle, and we have a side. Side, angle, side. Similarity theorem says these 2 triangles are similar triangles. All right, now let's look at our last practice for today. It is given to us a triangle XYZ and triangle DJG. Obviously, we're not going to use side because we see an angle here. The angle, this is 47, this is also 47. So for side, angle, side, we got an angle down. Let's look at the side. XZ and DJ should be corresponding sides. XZ and DG. We have XZ is 30. And DJJD is 50. So the ratio here is 3 to 5. And we got one side. Let's check the other side. The other side is XY. So we have XY to DJ, Jack. Okay, let's check this too. XY is 21, and this is 35. And we have, very good. And we also have a ratio is 3 to 5. Now we have side, angle, side. Let's write down the whole name. By side, angle, side. Similarity theorem. We can prove these two triangles are similar. All right, that is it. We're done with this triangle similarity problem.